Number Theory, Section 3, Congruences and Modular Arithmetic. Video 4, Euler's Totient Function. Euler's totient function is a counting function that counts numbers of positive integers which are coprime to a number n. So it's defined as follows. For a positive integer n, the totient function, which is written using the Greek letter phi, counts the number of positive integers m, where m is less than or equal to n, and m and n are coprime. So, for example, if we wanted to work out phi of 6, we would work out that of the numbers from 1 to 6, 1, 2, 3, 4, 5 and 6, well, 2 isn't coprime with 6, 3 isn't coprime with 6, 4 isn't coprime with 6, and 6 isn't coprime with 6. So that leaves 1 and 5, which are, so phi of 6 is 2. And with phi of 11, there are 10 numbers which are coprime with 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10 are all coprime with 11. So let's have a look at a function that could be used to check and find the totient function. So this is relying on a function that we used in a previous video, which was the highest common factor function. So I've reused that just here to say that if the highest common factor of my two numbers is 1, then I'm counting that towards the totient. And so the structure of this program is that we start off with the totient function being set equal to 0, and then it goes through every value in the range from 1 up to and including n, and checks for the highest common factor being 1. If it finds something where the highest common factor is 1, it adds 1 to the value of my totient, and then at the end it returns the totient. So let's have a look at that in the shell. So I've got my highest common factor function there from before, and I'm going to start by defining my totient function, which will take a value of n. I want to know the totient of n. And then I start by setting a variable called totient equal to 0, and then I check for I in the range from 1 up to n plus 1 if the HCF of n and I is equal to 1, then I found something that needs to be counted. So I say that my totient is equal to the totient plus 1. And then finally, I come out of that indentation and return the value of the totient. So let's try that out with the two examples that we just saw. Totient of 6 should give me 2, and totient of 11 gives me 10. Now it's interesting to consider what happens with Euler's totient and prime numbers. So when we worked out phi of 11, we got the answer 10. So in general, what's going to happen if we work out the totient function for a prime number? You might want to pause the video and just think about that for a moment. Well, what's going to happen is that for a prime number, p, then phi of p is going to be p minus 1. Because the only factors of p are 1 and itself, so that means that all of those numbers, 1, 2, 3, all the way up to p minus 1, have a highest common factor of 1, and it's only once we get up to p itself that the highest common factor will be p. So for any number less than p, the highest common factor of p and any number less than p is 1. You might also like to think about what the totient function would be for a square of a prime number. So what would phi of p squared be, or phi of pq, where p and q are distinct primes. So in this video, you've learned about Euler's totient function, which is written phi of n, and you've learned that phi of p is equal to p minus 1 if p is prime.